India's heat waves have tripled since the 1990s. Keeping buildings cool now devours more energy than almost anything else we do. But 30 meters beneath the Rajasthan desert, a stepwell built over 1,000 years ago is 6 degrees cooler than the scorching surface, and it runs on nothing. How were ancient civilizations able to cool entire structures without electricity? What these builders understood could reshape how we survive a warming world. Across India's biggest cities, the mercury now climbs to record heights, sometimes topping 48 degrees Celsius in Delhi, Ahmedabad, or Nagpur. In just 3 decades, the number of official heatwave days has tripled, according to the India Meteorological Department. Streets shimmer under the relentless sun, while concrete towers and glass-walled offices trap even more heat, turning neighborhoods into slow-cooking ovens. The electricity grid groans as millions of air conditioners battle the rising temperatures, pushing power demand to new peaks and leaving the poorest residents exposed when blackouts hit. National statistics reveal a stark pattern. In the 1990s, Indian cities averaged about 12 heat wave days each summer. Now, many cities face more than 35 days above 40 degrees Celsius, with longer, deadlier spells. The World Health Organization warns that heat-related deaths in South Asia have surged, and the risk is growing as climate change accelerates. Cooling buildings has become one of the single largest uses of energy in urban India, driving up carbon emissions and deepening the cycle of heat. Yet even as cities race to install more AIR conditioners, the question lingers. Is this the only way to survive the heat? Or did ancient builders know something we've forgotten? Did civilizations that faced the same sun, the same burning winds, find ways to keep cool without a single watt of electricity? In the search for answers, the story of India's lost cooling wisdom is more urgent than ever. Perhaps the future of sustainable living is not hidden in tomorrow's inventions, but in the forgotten wisdom of the ancient world. Centuries before electricity, Indian builders mastered passive cooling with a toolkit both simple and ingenious. Thick stone walls and floors, thermal mass, absorbed heat during the day, and released it slowly after dark, evening out the relentless swings of the climate. Evaporative cooling followed. Water stored in stepwells and pools was not just for survival, but for comfort. As it evaporated, it pulled heat from the air, lowering temperatures and filling shaded courtyards with a sense of relief that lingered even in the hottest months. Shading shaped every structure. Deep verandas, arcades, and overhanging eaves cast wide shadows, turning courtyards into cool sanctuaries and blocking the harshest sun. Natural ventilation animated these spaces. High ceilings, open corridors, and narrow shafts guided breezes. This stack effect, with hot air rising and cool air drawn in, kept rooms fresh without machinery. Perforated stone screens, or jalis, filtered sunlight and let air flow, balancing light and shade. Geometry itself became a tool. Builders oriented walls to catch prevailing winds or shield against searing rays. Underground chambers and sunken courtyards tapped into the Earth's steady coolness, offering escape from the heat above. Each mechanism, thermal mass, evaporative cooling, shading, ventilation, geometry, and underground design, worked in concert, creating buildings that responded to their environment. The wisdom of these ancient systems still echoes in stone and water, waiting for rediscovery. Stepwells and sunken courtyards across India reveal a hidden logic, geometry, as a climate machine. The shape of these structures was never accidental. Builders carved deep shafts, sometimes plunging 30 meters below the surface, with a narrow width that multiplies the cooling power of stone and water. This depth-to-width ratio, often between 1.5 and 3, transforms a simple hole in the ground into a natural engine for airflow and evaporation. Inside Chandbauri, Rajasthan, air moves at 0.42 meters per second, measured at the shaft's peak. This is not a gentle drift. As sunlight heats the stone, warm air rises rapidly through the narrow opening. Cooler, denser air is pulled in from the shaded lower galleries, setting up a continuous vertical current. This is the stack effect in action, a physics principle harnessed by ancient engineers long before the term existed. But air alone is only half the story. At the base, water glistens across broad, shaded surfaces. As it evaporates, it absorbs heat from the surrounding air, dropping temperatures by as much as 7 degrees Celsius compared to the world above. The effect is strongest where the steps descend deepest and where water is most exposed to the moving air. Modern computational fluid dynamics confirms what centuries of experience had already proven. These forms create their own microclimate, with measurable gradients of temperature, humidity, and airflow. Every step, every angle, every shaft opening was a decision rooted in physics. The result is a living experiment in sustainable cooling, one that asks, even today, did ancient civilizations understand sustainable living better than modern society? The answer may be hidden in the silent, spiraling descent of air and water, deep beneath the burning sun. Inside the stone labyrinth of Chand Baori, the difference is not just felt, it is measured. On a day when the desert sun pushes the air outside to 41 degrees Celsius, sensors placed at the top, middle, and base of the well tell a different story below ground. Compact data loggers, battery-powered, with no drilling and no damage, track every shift in temperature and humidity, capturing the hidden climate engineered by ancient hands. Midday readings show a consistent drop. Air at the bottom of the stepwell holds steady at 35 degrees Celsius, a full 4 to 6 degrees cooler than the blazing world above. Relative humidity climbs by 12%, making the air feel not just cooler, but softer, more breathable. These numbers are not a fluke. Handheld anemometers record air currents rising at 0.13 meters per second, enough to feel as a gentle draft on the skin, driven by the stack effect as hot air escapes and cooler air is drawn in. The evidence is clear. Stepwells like Chand Baori and Rani Ki Vav create their own microclimate, not through luck or legend, but through deliberate engineering. The cooling envelope, measured again and again across different sites, brings interior conditions into a comfort zone that modern air conditioning struggles to match. And it does so without burning a single watt. These results have been confirmed by field teams using infrared thermography and calibrated data loggers with temperature differentials and airflow mapped in detail. The implications ripple outward. If ancient builders could tame the heat with stone, water, and geometry, what stops today's cities from doing the same? Did ancient civilizations understand sustainable living better than modern society? Perhaps the future of sustainable living is not hidden in tomorrow's inventions, but in the forgotten wisdom of the ancient world. Inside the towering halls of Brihadiswarar Temple in Thanjavur, the air moves with a quiet purpose. Granite walls nearly a meter thick absorb the sun's heat, holding it back until nightfall. High above, a vaulted ceiling rises more than 13 meters, creating a vertical reservoir where hot air gathers and escapes through hidden vents. Perforated stone screens, jalas, scatter sunlight into patterns, cutting glare, and letting a gentle breeze pass through. Each corridor and courtyard is angled to catch the faintest wind, while shaded verandas and deep-set eaves shield the sanctum from the fiercest rays. This is passive cooling in action, an architecture of physics, not fuel. The numbers tell a story. A modern glass office in Delhi can consume 150 kilowatt-hours of electricity per square meter each year, just to stay bearable through the summer. Yet, temples like Brihadiswarar maintain comfort with nothing but stone, air, and geometry. The contrast is sharp. Today's energy-hungry buildings feed a cycle of heat and demand, while ancient sanctuaries turn the laws of nature into silent allies. In a world where cities now burn 3 degrees hotter than their surroundings, the question grows louder. Did ancient civilizations understand sustainable living better than modern society? Perhaps the future of sustainable living is not hidden in tomorrow's inventions, but in the forgotten wisdom of the ancient world. The story of India's cooling wisdom takes a sharp turn in the late 19th century. British colonial authorities, alarmed by outbreaks of cholera and plague, issued sanitary edicts that condemned open water bodies, including the stepwells that had cooled cities for centuries. Many were filled with earth, or sealed by concrete, their ventilation shafts blocked, their evaporative magic lost beneath layers of policy and fear. By the 1970s, urban planners favored concrete towers and mechanical cooling, sidelining the thick stone walls and shaded courtyards that once defined comfort. The rupture was nearly total. Knowledge passed down for generations vanished from building codes and engineering handbooks. Yet the story does not end in silence. In Patan, Gujarat, the restoration of Rani Ki Vav, led by the Archaeological Survey of India and recognized by UNESCO, revealed that the ancient step well still cools its inner chambers by 2 to 3 degrees Celsius, even as the world above bakes in the sun. Contemporary architects have begun to listen. In Hyderabad and Ahmedabad, retrofitting old buildings with water reservoirs and vented stone walls now cuts energy use for cooling by up to 22%. These pilots are not nostalgia, they are proof. The past offers a blueprint for the future, if we choose to remember. Perhaps the future of sustainable living is not hidden in tomorrow's inventions, but in the forgotten wisdom of the ancient world. Today's cities fight heat with more machines and more energy, while the climate only grows harsher. Did ancient civilizations understand sustainable living better than modern society? Perhaps the future of sustainable living is not hidden in tomorrow's inventions, but in the forgotten wisdom of the ancient world.